بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على حبيبنا محمد وعلى آله وصحبه الطاهرين. Good afternoon, my dear students, and thank you for joining this lecture in which we will explain some free solutions for cloud. So before starting this lecture, you are expected to be able first to define the well-used free solutions of cloud. Second, explain the OpenStack solution regarding architecture, regarding packaging, regarding development, and also explaining Eucalyptus and OpenNebula solution, and finally discussing the main key challenges in the cloud. So here through this lecture, we will focus on three main free solutions, which are the solutions, the well-used and the well-known solutions used by the enterprises, companies, individuals, and organizations. So here we will focus mainly on OpenStack. What is OpenStack? OpenStack is an open source cloud platform that manages distributed compute, network, and storage resources by aggregating them into pools and allows on-demand provisioning of virtual resources through a self-service portal. OpenStack is in fact a cost-effective extension of the existing public cloud infrastructure and a reasonable alternative to proprietary virtualization solutions. It enables organizations to optimize their cloud costs and service providers to build an infrastructure competitive to hyperscalers. In fact, OpenStack ensures what we call the TCO, which means the total cost of ownership. Since more and more organizations are using hybrid multi-cloud architecture, implementing a known cloud is a natural step once the number of workloads grows. Also, CapEx, which was explained in the previous chapters, costs associated with an initial deployment of OpenStack are high. It's an OpEx, costs are significantly lower compared to hyperscalers. As a result, the aggregated total cost of ownership, TCO, is lower when running workloads in the long term and at scale. This allows, in fact, businesses to optimize their cloud maintenance costs and service providers to build an infrastructure competitive hyperscalers. In fact, OpenStack is more than virtualization. So unlike traditional virtualization management platforms, such as VMware vSphere, OpenStack is a fully functioning cloud platform as defined by the National Institute of Standards and Technology, NIST. This means that OpenStack basically resembles the behavior of public clouds. So here, users can request compute, network, and storage resources on demand through a self-service portal. Also, they are provided in the form of virtual machines, virtual networks, and virtual disks, exactly as in the traditional virtualization management platforms. They are defined through the APIs. For businesses, the ability to define virtualized resources programmatically enables fast-paced infrastructure automation and cloud-style operations. Now, let's explain how does OpenStack work. In principle, OpenStack aggregates physical resources into one big pool and allocates virtual resources out of this pool to users who can request them on demand through a service portal or application programming interfaces, APIs. But OpenStack itself does not handle virtualization. Instead, it leverages the existing virtualization technologies. Therefore, OpenStack is more like a wrapper around traditional virtualization tools, enabling cloud-native capabilities. To define, deploy, and configure an OpenStack solution, administrators must understand the logical architecture. As the architecture principle shows, OpenStack consists of several independent parts called OpenStack services. All these services can be authenticated by a common identity service. So individual services interact with each other through public APIs unless privileged administrator commands are required. Internally, OpenStack services are composed of several processes. All services have at least one API process that listens for API requests, processes them, and forwards them to other parts of the service, except for the identity service, where the work is done by separate processes. For communication here, for communication between processes of a service, an AMQP message allocation manager is used. The state of the service is stored in a database. So when deploying and configuring your OpenStack cloud, you can choose from several message handlers or databases such as MySQL, MariaDB, and SQLite. So here users can access OpenStack via a web-based user interface, which is called or which is based on Horizon, implemented by the Horizon dashboard via a command line client and by issuing API requests through tools like browsers, plugins, or curl. For applications, several SDKs are available. Ultimately, all of these access methods issue REST API calls to the various OpenStack services. So, the following diagram shows the most common OpenStack cloud architecture, although it's not the only possible one. In fact, OpenStack was originally launched in July 2010 by Rackspace and NASA as an open source initiative that combined NASA Nebula platform and Rackspace Cloud Files platform. Today, hundreds of companies contribute to OpenStack code, with many more playing a part in the broader community. Here we have some companies as platinum members such Red Hat, Microsoft, Meta, Huawei, FiberHome, and so on, and as a golden member such Intel, Cisco, HBC, NEC, Clara, Bloomberg, and so on, and as also silver members such Fujitsu, NTTX, Entity, Courage, Samsung, Sardina, VMware, and so on. Here we have also some infrastructure donors such iWeb, OpenMetal, or OVH Cloud and Rake Space. Now, how or who use OpenStack? In fact, there are thousands of OpenStack users across a broad range of industries, particularly favored for its stability, security, and interoperability. Apart from telecommunication service providers, financial institutions, enterprises, government, militaries, universities, and research institutions all over the world, further adoption of OpenStack has been also seen in healthcare, retail, and industry. Here we have some statistics regarding the community using or contributing into OpenStack. We have here about 850 individual members, a total of developers for 2,130, and an average monthly contributors, which is about 374, and 187 countries. Here we can just stay or cite the important countries such United States, China, India, UK, France, Russia, Australia, Canada, Japan, and Germany. According to 450 research market monitor from September 2019, OpenStack's combined market size worldwide in around $8 billion. It also continued to be one of the top 3 open source projects in the world in terms of active contribution, along with the Linux kernel and Chromium. In 2020, OpenStack reached its 10-year anniversary, which proves its maturity as a software project. Governed by the Open Infrastructure Foundation, more than 34,000 individual contributors and 550 companies participate in OpenStack development. It is also the most popular open source private cloud platform, and its adoption continues to grow. Now, what can we do with OpenStack? With OpenStack, we can build a private cloud, a public cloud, and containers. For the public cloud, OpenStack allows organizations to bootstrap their own private cloud infrastructure by benefiting from maximum cost optimization in multi-cloud environment. For the public cloud, not all countries all over the world can leverage on the hyperscalers. So OpenStack is an obvious choice for local service providers willing to build their own public cloud infrastructure. Finally, for containers, OpenStack can be easily extended with a container layer running on top of each for better workloads granularly, as required by cloud native applications. Now let's explain the packaging in OpenStack. Enterprise Linux distributions here are crucial for organizations looking to ensure stability, security, and support for their IT infrastructure. This comparison covers 5 popular distributions: Red Hat Enterprise Linux, which is known as the RHEL, SUSE Linux Enterprise Server, which is known as the SLES, Oracle Linux, Ubuntu Server, and CentOS Stream. Each has unique features, advantage, and consideration. Let's start by Red Hat. Red Hat Enterprise Linux is one of the most widely used enterprise Linux distribution, known for its robust performance, comprehensive support, and extensive ecosystem. Its key features are about stability, security, support, and ecosystem. What we mean by stability, which means a long-term support with a 10-year life cycle, including regular updates and security patches. For the security, enhanced security features like Cell Linux, security advisories, and compliance certifications. For support, 24/7 support with various subscription levels, including access to Red Hat, knowledge base, and customer portal. And for the ecosystem, it's about integration with a wide range of Red Hat products and services, including OpenShift for Kubernetes and Ansible for automation. This is what about the Red Hat Enterprise Linux. What about SUSE? SUSE Linux Enterprise Server is known for its flexibility, performance, and strong support for various hardware platforms, including IBM Power and mainframes. Its key features are about flexibility, performance, support, and management tools. We have also Ubuntu Server, which is known for its ease of use, rapid release cycle, and strong support for cloud and container deployments. Its related or its key features are ease of use, release cycles, cloud and containers, and also cost effective. Now, let's explain DevStack and PackStack. DevStack is a series of extensible scripts used to quickly bring up a complete OpenStack environment based on the latest versions of everything from Gridmaster. It is used interactively as a development environment and as the basis for much of the OpenStack project's functional testing. For PackStack is an OpenStack deployment tool intended to install proof of concept small environments in a quick and easy way using the RDO distribution, which is the rapidly deploy OpenStack on a CentOS Stream host. So this is what about DevStack and PackStack. So you can get an access to these modules through the following web links. Okay. Regarding development, in OpenStack, which is initially developed based on Python, which is open to all for individuals and enterprises, now let's explain the OpenStack architecture. OpenStack is composed on independent components which communicate with each other via a queue, such Rabbit MQ or AMQP protocol, and which can exchange information via the APIs they expose. Okay. As shown here in the following figure, OpenStack architecture, we note that the main components or services of the OpenStack cloud model are controller, compute, and networking. For the controller node, hosts all OpenStack services needed to orchestrate virtual machines deployed on the compute nodes. For high availability, it is recommended to deploy at least 3 controllers to provide multiple controller nodes. Secondly, compute node, which is in many ways the foundation of the environment. It is the server on which virtual hosts are created and applications are hosted. So compute nodes need to communicate with controller nodes and access essential services such as MySQL. 3, an OpenStack environment includes multiple servers that need to communicate with each other and to the outside world, and the network node serves that purpose. It supports both old Nova network and the new Neutron-based OpenStack networking implementation. Now, for the first access, and when you have get access to OpenStack, you can get this interface. So upon logging into OpenStack and the Horizon dashboard, you will see the main projects here, tab in the left-hand corner. Items under the project tab allow you to view and manage resources in a selected project, like instances and images. You can toggle between projects by using the drop-down menu in the upper left hand corner. You can also select a different domain from this model if you are cloud supported. Within the project tab, you have the ability to view and configure additional settings tabs that will help you manage your instances. These additional tabs could include the compute, volumes, container, network, or orchestration, and object store. For example, the compute tab here contains the following view and options: an overview, instances, images, K-pairs, and server groups. So through the overview, you can view reports for the project. For the instances, it allows you to view and launch an instance. So you can also create an instance from a snapshot and stop, pause, or reboot instances. For the images, it allows you to view images and instance snapshots, as well as images that are publicly available. You can launch instances from images and snapshots and create, edit, and delete images. For the K-pairs, it allows you to view, create, edit, import, and delete K-pairs. For the server groups, it allows a server group to be assigned to launch the instance. For the volumes tab, it contains the following view and options: volumes, backups, snapshots, groups, and group snapshots. Volumes allows you to view, create, edit, and delete volumes. For backups, it allows you to view, create, edit, and delete backups. Snapshots allows you to view, create, edit, and delete volume snapshots. Groups allows you to view, create, edit, and also delete consistency groups. For group snapshots, it allows you to view, create, edit, and delete consistency group snapshots. Inshallah, we will explain all these services in a practical way. And I will show you how to use OpenStack and how to create instances. Now, let's explain the architecture of OpenStack and what it hides. OpenStack Glance has a client-server architecture that provides a REST API to the user through which requests to the server can be performed. A Glance domain controller manages the internal server operation that is divided into layers. Specific tasks are implemented by each layer. All the file or image data operations are performed using Glance Store library, which is responsible for interaction with external storage backends and or local file systems. The Glance Store library provides also a uniform interface to access the backend stores. Glance, in fact, uses a certain database, which is known as the Glance DB, that is shared amongst all the components in the system and is SQL based by default. Other types of databases backends are somewhat supported and used by operators, but are not extensively tested upstream. The following components are present in the Glance architecture as shown in the following figure: a client, the REST API, and a database abstraction layer, a Glance domain controller, a Glance store, and a registry layer. So for client, is about any application that makes use of a Glance server. For the REST API, so Glance functionalities are exposed via REST. For database abstraction layer, which is known as the DAL, which is an application programming, or which is based on an application programming interface API that unifies the communication between Glance and databases. For the Glance domain controller, which is a middleware that implements the main Glance functionalities, such as authorization, notifications, policies, and database connections. For the Glance store, it is used to organize interaction between Glance and various data stores. And finally, the registry layer, which is an optional layer that is used to organize communication between the domain and the DAL by using a separate service. Now, let's explain the three models or services in OpenStack related to computing, storing, and networking. As explained here, OpenStack is based on a modular architecture. There are six primary OpenStack components that handle compute, network, and storage. A bunch of other components enable additional features, such as dashboarding, the parameter provisioning, containers, secrets management, and telemetry. So in order to handle this complexity, organizations often use OpenStack charts for fully automated OpenStack installation and post-deployment operations. Now let's explain independently each service regarding computing, regarding storing, and regarding network. For the authentication or authorization, which is known as the identity service, here we use Keystone model or Keystone service. Keystone provides a central directory containing the list of services and the list of OpenStack users, along with the roles and permissions. Within OpenStack, all services and users use Keystone to authenticate with each other. Keystone can interface with other directory services like LDAP. It supports also multiple authentication formats like passwords and others. For Nova, which is related to also computing, Nova is one of the main bricks of OpenStack. Its purpose is to manage the computing resources of infrastructure. To do this, Nova controls hypervisors via live or directly through the APIs of some hypervisors. Today, the best supported hypervisors remains KVM. But Nova also works with Xen or ESXi and Hyper-V, or even with container managers like Docker. So the architecture of the Nova brick is designed to evolve horizontally by adding hardware. Okay. Now, what about Glance related to images? Glance is an image service responsible for uploading, managing, and retrieving cloud images for instances running on OpenStack. Glance works across a variety of stores to provide the most convenient location of images for organizations. Now, what about Neutron, which is related to networking service? OpenStack Neutron service allows you to manage and manipulate networks and IP addressing within OpenStack. So with Neutron, users can create their own networks, control traffic through security groups, and connect their instances to one or more networks. Neutron also manages the IP addressing of instances by assigning them static IP addresses or through the DHCP service. It also provides a floating IP address service that can be assigned to instances to ensure connectivity from the internet. These floating IP addresses can be reassigned to other instances in the event of maintenance or failure of the original instance. In fact, Neutron provides different types of network deployment depending on the target infrastructure. So the most deployed types of networks are flat networks, VLAN, which is the virtual local area network, VXLAN, or GRE-TON networks. It also manages its deployment using the add-ons that allow it to communicate with network management equipment or software. The most used plugins are Open vSwitch or ML2 or Linux Bridge, but also Cisco Nexus, Juniper Open Controller, and others. In the architecture of Newton. Newton was with following the philosophy of next generation networks called SDN. Also, it does not manage itself. Some plugins take advantage of the SDN features of the equipment they control. So when used with Open vSwitch, for example, Newton uses a combination of IP tables and OpenFlow rules to manage traffic to the instances. So regarding, this is Horizon, which is a dashboard of OpenStack, which is a graphical interface and which allow us to manage or use or select resources. So regarding Cinder and Swift, as mentioned here, Cinder and Swift are related to storage service. For Cinder, it provides persistent block devices to OpenStack compute instances. It manages the creation, attachment, and detachment of these devices on servers. In addition to local storage on the server, Cinder can use multiple storage platforms such Vmax or VNX or Ceph or ClusterFS, and also IBM storage, including GPFS or Storwize family, and so on. The block storage is used for high performance scenarios such as database storage, but also to provide the server with low level access to the storage device. Cinder also manages the creation of snapshots, which is very useful for backing up data contained in block devices. Snapshots can be restored or used to create new volumes. This is what about Cinder. For Swift, Swift is a redundant and scalable data storage system. So files are written to multiple hard drives distributed across multiple servers in a data center. It ensures data replication and integrity within the cluster. The Swift cluster scales horizontally by simply adding new servers. So if a server or hard drive fails, Swift replicates its content from active nodes in the cluster to new locations. Since all Swift logic is application-based, it allows the use of inexpensive and non-specialized hardware. Okay. Now, let's explain the Open Nebula and eucalyptus. OpenEbola is in fact an European project developed by a Spanish company in 2008. It's an open source cloud solution under the Apache license. OpenEbola is written in C++ language, Ruby, and Shell. It provides a set of functionalities that organize the operation of a set of physical servers providing resources to so-called virtual machines. For Eucalyptus is also an open source cloud platform used by Amazon EC2, which is related to virtual machines, and allows also the installation of a private and hybrid cloud infrastructure. It is also written in Java, C, and Python. Inshallah, we will explain both Eucalyptus and OpenEbola in the second part of this chapter, inshallah. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.